Hello, we are Group 175, consisting of members Danny Rivera, Spencer Lowe, Jamie Sanchez, and Sarita Ravi. And in this video, we'll be doing an overview of our project, which aims to use economic variables to predict hurricane damage in 4 states, which include Florida, Texas, Louisiana, and North Carolina. Our research question is as follows. How can economic variables predict a U.S. county's reported hurricane damage? Do counties with weaker economic factors, such as GDP and personal income, suffer more infrastructure damage than counties with stronger economic factors? For this project, we became very interested in observing climate change-related disasters. More specifically, we wanted to see if there could be any patterns between economic factors and the property damage that these counties experience, especially following the news of Hurricane Helene and Milton earlier this year. Our hypothesis is as follows. We predict that there is a relationship between economic variables and the magnitude of damage U.S. county experiences from hurricanes. We hypothesize that counties with higher GDP and higher personal income numbers, both in USD, will have an easier time recovering from hurricanes in comparison to U.S. counties with low GDP and lower personal income numbers. Our first dataset, which looks at economic data for 2022 for these 4 states, was found from the U.S. Bureau of Economic Analysis database. Our second dataset, which looks at hurricane events, is from NOAA Storm Events database. It looks at reported events in these 4 states from 2012 to 2024. After cleaning and merging both datasets, our final dataset had 100 observations across 11 columns.
One important column in our dataset was real GDP, which looks at the GDP in USD reported for each county in 2022. Here we see that the average GDP was $9.1 million. The lowest and highest reported GDP were 162,000 and 180 million, respectively, which shows a lot of variability. We then looked at the total personal income per county, and these numbers are more normally distributed. The average total personal income was around 10 million. However, we still have a lot of variability here too, so we looked at the personal income per capita next, and the average person's income was $52,000, but there were some outliers, and the largest reported income was over $131,000. Because of this, our distribution is very heavily skewed to the right. Lastly, we looked at the reported property damage from hurricanes. As you can see, there are many outliers, with some counties reporting zero property damage, and some of them reporting much more than that. However, the average damage cost was somewhere close to $544.4 million. The highest reported was $7.3 billion, which is much higher. We then ran an inferential analysis to try to look for a relationship between these variables and see if we could predict property damage. We started by running an ordinary linear regression between property damage and two separate economic variables, real GDP and personal income per capita. When looking at real GDP, we can see that there is very weak correlation. This, as well as our low R-squared and high error, show that GDP alone is not a reliable predictor of property damage. Next, we looked at personal income per capita versus property damage, and here we can see that there is a slightly stronger relationship, but there is still a very low correlation, and we can see that our model to predict still performs quite poorly. Right. So why did it fail? Our models likely performed quite poorly for a number of reasons. There may have been other factors or confounding variables affecting our results that we didn't take into account. It may also be that we need a more complex model to create more accurate predictions. Another explanation could be that our data did not have enough information for our models to be reliable. For example, we only had 100 observations in our data frame. We could have expanded it or included more states to get more observations. It may also be that we needed more data for other variables to make more accurate predictions, such as looking at other measurements for hurricane damage or economic factors. Based on our results, we failed to reject the null hypothesis. While our results were not significant, we can keep these concerns in mind to retrieve more accurate data or create a more complex model to accurately predict hurricane damage. As climate change creates more frequent and disastrous hurricanes, it will be even more important to find ways to predict and prepare for these disasters in the future.